right, happy Thursday again. We've got a fun-filled night tonight. No new project, right? Hopefully you got a chance to start working on Yahtzee. Lots of fun. Just a couple notes from talking to a couple of you. It does not need to look exactly like the website. Okay, that is one UI. It's not the only one. So let me show you what mine looks like. It doesn't have to look like mine either. This is just an idea here, if you want ideas. Okay, so this is the one I built last time around. I am not a UI designer. Please don't laugh at me. It's functional. Okay, that's all we need is functional. This is what I got. I got numbers, I got checkboxes, I got buttons. That's it. This is perfectly fine. I would give myself 100%, of course. So if yours is prettier, even better, go for it. You can make it look pretty. You don't have to make it look pretty though. Okay? So as much fun as you want to have with it, go for it. So I liked having just one set of scores showing at a time rather than the columns. I thought that was easier. And this way you can really have like n number of players. Right? So if I wanted to have 5 different players, I would need a way to start with 5 players again, but you know, the next, after you score, it goes to the next player. And we can just keep on recycling player, you know, put a bunch of players in a list, and now I can go for n number of players if I want. Yahtzee actually gets really boring when I play with all of my kids, if the little guy doesn't play. But you know, if 7 of us are playing, you spend a lot of time just sitting around waiting, unless you have lots of dice. And I happen to have lots of dice because I play D&D. So we can all be playing at the same time. And then it's not really as much fun because it feels like you're just playing against yourself. So there's like a sweet spot in there, probably like, you know, three to 4 people. It's pretty good for Yahtzee. Okay. Again, you don't need the bonuses. That's more stuff than we need to do. If you want to do it, go for it. The hard part should not be figuring out how to score this stuff. Go ask the chat bot. Right? That's perfectly fine. Just like your source, right? Drop in a code comment, be like, hey, ChatGPT, I asked how do I find a full house, or whatever, you know, come up with something like that. That's okay. You're still gonna have to wire it up to the UI anyway. All right, so if you look at the scorecard here, the rubric, that's what it's called, the rubric. I was just the Yahtzee scorecard, that's what I was thinking here, right? We've got classes for the business logic that the UI interacts with. So the game should be playable any UI I want. I could build a web app, I could build a mobile app, I could build a console-based app, I could build a graphical user interface app. GUI is a fun word to say, right? Build a GUI app. Sure, it's the exact same class. It doesn't care what's calling it. And you can do all of those in C# because Microsoft is fun like that, right? We could build it in Maui to make it a mobile app. We could build it as a web app. I wish we had time to do web apps, but there's a whole other class for that, so we don't do web apps here. That sort of thing. And then like, it actually doing the right thing here is only 5 points out of the 20. And then we're gonna unit test it because you probably got this stuff from Chatbot. It will make stuff up all the time. Right? The large language models are designed to be prose machines. They're designed to imitate what it thinks is what it looks like an answer. Right? It's really bad at math, and it will like ask it to like check its own math, and it'll like give you this whole proof of why 7 + 2 is 4. I mean, it's pretty good up to like 3-digit numbers. After that, because it just looks like answers, it just starts making crap up, which is fun like that. So we're going to write the unit test and say, okay, if I have a 1, 2, 3, 4, and 5 on my dice, and maybe mix up the order a little bit here, just for fun, like a 2, 3, 1, 5, 4, right? Is that a large straight, right? And we can test that sort of thing. So we're going to write the unit test for it for 5 more points, okay? This shouldn't take more than like 10 hours or so, right? Ideally, you're spending 2 hours outside of class for every hour in class. This is 3 credits, so it's like 6 hours a week worth of homework. Right, including your reading and your studying and the quizzes, which I did post early. So the quiz for tonight and yes, last week, I posted already. It's due next week. So hopefully I'll stay on track with that here and keep the quizzes going. Yeah, does that make sense? Questions about this? We feeling okay so far? Again, if it's taken more than 10 hours, like, you know, if you feel like it's going to take you more than 10, like reach out to me, you know, halfway through, even less than that. So I generally ask you to like bang your head against the wall for a good hour before you come ask for help. Like if you get stuck on something, after that you're just going to feel bad about yourself, you're going to feel bad about me, you're going to feel bad about C#, and we want none of that. Okay. Elmo wants to check in on you, see how you're doing. The whole Sesame Street gang's there for your mental health. Plus we got the CAPS program, like actual professionals, not Elmo and puppets, although puppet therapy might be good for some of us. I don't mean to make light of that, I apologize. That's a serious topic. Sorry. Okay, new stuff? Cool. Let me pull up Visual Studio. Oh, I closed them. Could have just opened a new thing. So this is going to be, what week are we in here? This is week 5? 4? Week 4? Week 5? Can't count. What? There it is. Yeah, week 4. Okay, week 4. Make a new project for week 4. Should we do a graphical app again? Let's do another graphical app. Why not? This is week 4, more object-oriented. Oriented. That's probably spelled close to right. All right, now I gotta grab the book real quick because I want to make sure we're sort of following along with those chapters. I didn't put it in here. Where did I put it? There it is. Yeah, so we made it through properties or so, right? We didn't get to static or null references or anything. Did properties. This, like computed things or, do we do properties? Do we not do properties? How far did we get?
I think we did properties.
Information hiding in properties? Okay. Yeah, these like expression-backed properties, right? So you could have something that looked like a property for area, but it was not readable, right? You can make private values if you want this area. Okay, a couple of people are shaking their heads. We're good. All right, so static things here. Works the same way it did in C++. So static things belong at the class level and defined once for the class, and they're shared among all instances of the class, if you wanted. So if we wanted to write a, let's do a new class in here. So the project, I'm going to go add a new class. Everyone loves the student class, right? It's relatable. You like to use examples that are relatable, right? So class for student. So properties of student, things, attributes that you students have, right? You probably have an int as an ID number. We can do gets and sets. Probably a private set on that, right? I don't think you ever really change your ID number once you get assigned one, right? You probably have a string for name, lowercase s. String for name with a get. Now that one is changeable, right? What? Access button up. I'm confused. I think it just needs a second. I think it's probably confused. All right. So ID number, we get name. What else? What other things do we know about student? Do you have like an address? Maybe?
Phone number, email.
Phone number, yeah. So string for phone. Oh man. With the gets and sets, string for email. Gets and sets. That's fun. Okay. So if your ID number is not settable here, but we want to like have some sort of way to track ID numbers among students so you don't get the same one, we could have a static attribute for ID number that gets incremented every time we make a new student in memory. That's a pretty common thing we can do. So we can have a static, this is our, what, I don't know, next ID number. Oh, int next ID number. We probably start that off at 1 or so, right? There's probably no student 0, or maybe, you know, because you all get 7-digit numbers or something. Right, we can throw an underscore in here. Digit separators are amazing. So when we make a new student, all right, that's going to bother me here. Is it Visual Studio just being dumb? I think it's just being dumb, right? It is, okay. No, it was away for a second. ID number. Maybe it'll figure it out here. So if you want to make a constructor for student, right, you probably need a string for name. No, string for name. Probably need a string for your phone, string for your email. And maybe we could default those to nothings if we don't know otherwise, right? Because everyone loves having blank data in your database. Don't set name is name, phone is phone, email is email, and then your ID number, we could equal to the next ID number plus plus. This is just fun, do it all in one line, right? Take the number and then add 1 to it. Take the number and add 1 to it. So each student will have a attribute of the ID number. That's what it's missing, private. it say private ID number? Is that happening now? No, why is it upset? That's going to drive me crazy. Accessor must be more restrictive than the property or indexer. Student ID number. Private, public. We have to, I got it. So by default, right, we're getting things that are not public. So you have to specify it's public here. That way we can have our private set. All right. So we can make students. Right? So if I wanted to have a button in my form, because we love buttons, let's add a button. And we'll add maybe a text box. No, text box, there we go. And a label. We'll say name here. It doesn't even have to line up, that's okay. So when you click the button, we'll do something here. So let's make a student. So maybe my form here then might have a list of students. I might have a list of type student, call my students. Look at that, great suggestion. I can take a students and I can add a new instance of the student class given. Now I need a name. Well, name should be my name text box, which I forgot to name here. Let's go back and give this a name. This is the name text box. Name text box. Where is it here? Name text box dot text. We'll add the student to the list. Right? And then maybe we want to spit out a bunch of stuff about student somewhere, right? So this will be, you can call this like add student. Add student. Now we have blanks so far for phone number and email address. We can come back to those later, right? Then maybe we'll set up a label. Let's do our label. And we'll call this students. Here's our student label. Student label. Okay, so we have the student label. So when I click add student, we'll make a student, given the name, add it to the list here. Probably want to clear out that text box so you can't like click 3 times and add a bunch of Erics, or like if your mouse or your cat steps on your mouse, it's the wrong animal. It doesn't add a bunch here. So I'll take my name text box dot text and set it to empty. There we go, we could do that. And we could even check in here, right? Hey, if my name text box dot text does not equal string dot empty. If it's not empty, let's go do this stuff, right? If it is empty, I just ignore your click, right? Because I'm not going to add a no-named student. That doesn't make a whole lot of sense here. We can add some sanity checks if we want and blank it out here, and we'll take the student's label and we'll set the text, right, to something. I think it started off as students, right? So students. And then we want to add in an environment new line, because that's the fun way to do this, right? And we probably only need to change that label if something happens too. And we can say for student, colon student, or in students, there we go, in students. Right, do a little loop for each. We can take our student label dot text and we want to append to it the student plus the environment new line. Right, take the student as a string, append it in. So we should be able to add a bunch of students. Right, here's test. Oh wait, we get garbage here, right? It doesn't know how to represent a student as text yet. Right? We don't have a toString method. So we could write a toString method. Come to our student class. So public string, toString, at the override, right? Override, string toString. Eventually we need to return a string, so we can return our formatted string as name, or what, ID number, colon, name, I don't know. We don't have phone and email anyway, but we could eventually, right? So if I want to represent a student, here I get the ID number and their name. Now when we add something here, we see test, we get student 1 million, test 2, student 1,000,001, test 3. You know, I should have hooked that up so I can hit the enter key on here. That'd be nicer, right? We could do that. I think we did that two weeks ago when we did UI stuff. I'd have to go Google it again because I don't remember, but that's okay. Does this seem to make sense? We just keep on going. So that's a static attribute of the class. And now every time I hit run, right, it's going to start back in 1,000,000. So this is not really how we do it with the database. And we'll get to database work in a couple more weeks, where we'll actually store this stuff in a database, which is the right place to store these sorts of things. But we could have static class attributes. They're useful for things like this, things that belong once to the class, right? Not every single instance. So you can do a couple fun things with it too, with these static attributes. All right, so static. I'm sorry?
How does it get updated every time you like add one?
Our plus plus here. So we're saying use the number and then plus plus add 1 to it. So we're like grabbing the number and updating all in one with this little plus plus thing. So it's one of the fun uses of this without having to update it separately. All right, so static, get points, sure. Other cool things you can do with static. If your methods don't need access to your attributes. Here. Now, depends on what we're doing. It's like the math library, like math.power or something, or math.cosine. It doesn't need an instance of math to figure out the cosine of an angle, right? You don't need to have a new math around. So that's the other thing we can do. We can have static methods that just do something in a library. We don't need to have an instance of, student probably doesn't make a lot of sense for this, but other examples right there, math libraries are a really good one, right? You don't need the instance to do any of these functions. So depending on the code we're writing, we could write static functions. And it'll actually suggest it to you. If you're not using any of the attributes in a function, it'll suggest you can make it static. It's one of the nice helpful things it suggests sometimes. Student's not a great one. Here, hang on, like public int charge tuition. So we're going to return, was it $6.75 a credit or something per credit? Something ridiculous, right? So we can charge a bunch per credit. It doesn't need an instance of student. Right? It doesn't matter which student you are. And technically this is true, right? But then you get charged extra for upper level classes because we have the tuition extras because they wanted to advertise one flat rate, but it's not actually one flat rate, right? So there's a bit of more interesting stuff that goes into it, but essentially it's the same thing. And I think, is it suggesting? No. There it goes. Make static. Like, hey, this could be static. It's suggesting we could do. Because it doesn't use your attributes of student. So this could be a static method here. Because it's the same, technically the same, right? We would add in the extras after, of course. All right. Null reference stuff. Nulls are the bane of our existence, right? Because they crash our programs when you try and do stuff on nulls, right? So if we weren't careful here, right, we said, that's our form class here. This is technically a little bit ugly. And initializing a value here where we're declaring it, it's not super proper. It'd be better to put this in the constructor because the constructor's job is to give your attributes values, right? That's the constructor's job. But if we forget to do this, right, if you forget to give an attribute values here, we comment this out. And we go to use our student class here. Now it crashes. Object reference not set to an instance of an object. These are no fun here. So stuff could be null if we're not careful. So some of the cool things we can do is we can check for null before we do something, because we don't want to crash here. So again, depending on our code, we can do all sorts of fun things, but we can say, hey, students, question mark dot add. So the question mark here says, if it's not null, keep on going. If it is null, please stop. So it won't crash here. Right, so if okay, that's crashing my for each loop, but the add line doesn't crash. Right? My for each loop crashes because this one's null. We could add one more check. Right? If students is not null, look at that, it's even suggesting if students is not null. I love it. No, did I cut? I thought I cut. Paste. Now we can get it to not crash on us, right? So it just does nothing here. Probably not very useful, right? But when you're working with objects and they're coming from other places, right, if you're not responsible for this student's argument here, We might have another class, like, hey, I might have a class for class, and that class might have a list of students, because then I know who I'm teaching. Right? Maybe that class isn't giving me back a list. Maybe it's returning null, because you can do fun stuff like that. Right? So if we had another class here, maybe we'll call it section. Probably section I think makes more sense, right? So section is going to have a list of type students. It'll have a, I don't know, string for the instructor. It'll have a string for course code. Gets and sets, yeah, gets and sets. Now, gets on lists are a little bit weird, right? When we're passing lists around or vectors around, you're probably more familiar with vectors. You gotta be careful because they're modifiable. So if we make this a public get, people will be able to change the contents of the list. Just like you could change the contents of a vector. They can't reassign it somewhere, but they can go and take students out, add students in, do all sorts of funny things. So if I make it a public get, I have to be a little bit careful. And I probably don't want that to be a public set either. I'll make that private. Right. So you can have students, instructor, course code. So then to make a section, you probably need to tell it a string for instructor and a string for course code. So we can say the instructor is the instructor. Oh, let's capital I instructor. There we go. It's my property, instructor. And the course code equals the course code. And then I'll say my students equals a new list of student. It's empty for now. Maybe in here we could add a method for add student. I love it. Keep suggesting things for me. And maybe if student is not null, let's go add the student. Right? Because anytime we're taking something that's a reference type, which is everything but our primitives, so basically everything with a capital letter. This is all of our classes. So ints and doubles and floats and chars are considered primitives. They're just, here's your value here. Anything that's a capital letter, these classes here are going to be reference types. So what you pass is the memory address. Where does this thing live in memory? That way we don't have to make copies of things all the time. So a memory address could be null. I could give you nothing. So we can check for that and say, hey, if you gave me a nothing here, don't do anything. Otherwise, go add it. Otherwise, I would add a bunch of nulls, and that's no fun. So we can add student here. Let's see. So then, yeah, public get. So then our form then, maybe instead of having a list of students, maybe it now has a course or a section. Right, so maybe we have a section, section, and then in our constructor, we can say section equals a new section, given, what is it? So that's me and then CIS 297. So when you want to add a student then, instead of adding it to our own list here, we can add it to the section. Add student. Make a new student here. And then if my section is not null, I'm going to go through for each section dot students. Oh, that came out weird. That should have been lowercase. Uppercase. Uh-oh. I didn't fix that one. I should have used the rename. Have you seen the rename? Right, you've seen that, right? You can right click and say rename, and it'll rename it everywhere, in all the places, and across your solution. Okay, that's a great shortcut. So I can get the list of students out here, but because this has the public get, if I wanted to screw around with this list here, I can go do funny things to the list and go add more students or remove students, or you might not want that to happen. So this might not make sense to be a property here, right? You could instead write a method for this, right? Or I think we can specify the get in here, right? We can do get, oh, what is that weird syntax? We can specify, I have to go copy it from last time. I always forget. We can just get rid of that. Let's do a private list of students. And then we can add a method, public list of type student, get students. Then we can return my students dot, students. Where's my copy? Clone. Students dot, where is it here? I've got one of these will give me a copy. There's too many options here. No. Where is it here? Am I missing copy? I don't think, I don't want to copy to a new list. Is that what I want? Hang on, C# make copy of list. I'll just Google it here. Yeah, not a list clone. Really? That's gross. Okay, I guess we do copy too. None of those are fun. New list. Oh, here we go. Is this a new list of type student? There. So we should have an override in here that takes a collection of students. That's what we want. So the list class has a way to copy from another list. That's what we want to do. So I can give it my students list here. So this will make a new list given the old list. So now if they try and modify it, they're not going to change my list. Only the section class can change the list of students. Right? If that's what our code should do to make sure that when I give people this list of students, they can't change it, we can protect it. Right? That's one of the goals. You want to make sure we're protecting our attributes. Right? Who knows what someone's going to do once they get the list? Because they have full access to add and remove things if we give them the original list. So if that works, if that makes sense for us, we do it. And it's not students here, now it's get students. Oh, that should have been uppercase though, right? Rename, call that get students. The naming convention gets weird sometimes. All right, so now we should be able to go and add students. Test, test 2, test 3, right? Doesn't really look any different than before, but now the section class has the list of students, okay? But again, we might run into null issues, right? If we screwed this one up here and get students returns null, well, now I might not be able to loop over anything, right? So if we just go and cheat here, let me comment this out for a second, and return null. This is valid code, not good code. It's valid code, it compiles. But when you expect to get something back and you give someone a null, you've done a weird thing, right? It's probably no good. And now we crash because get students returns a null, and we're sad. So we could, if we wanted then, have to null check everything. Right? And before, anytime we get back a reference type, we can check, hey, if my section.getStudents is not equal to null, then go do some code. Right? And now I feel bad because I have get students twice, and so maybe I have var students. And this is where var comes in handy, because I don't care what the type is, right? I can just say, hey, whatever type I get back from my method here, save it. Right? I don't have to type it out. And it knows what type it is, because when you wrote the method, you said I return this type. Right? The compiler knows. We don't have to write it down. This is why people like the not strongly typed languages, because the compiler usually knows what type it is. The compiler is a lot smarter than we are. Right, so we can do null checks if we want. Then we're back to where we were, where it won't crash on us. Right? Probably would want to have some sort of error message, or hey, something unexpected has happened. Go to contact your system administrator. Your poor sysadmin doesn't care, which drives me crazy. The Echo Dot system and the Alexa system that Amazon has. There's this huge company, and I guess it makes sense. They don't want people calling when their Echo Dot, their grandma can't work the Echo Dot. But when I can't work the Echo Dot, it's got to be a bug. When grandma can't work the Echo Dot, she's just not doing it right, obviously. But they're like, hey, if you're experiencing problems, go give feedback in the Alexa app. Feedback is not help. I'm sure that feedback goes into an empty bucket somewhere, right? That little round filing can that people keep under their desk. Okay, so we can null check. Null checking is great. So giving, you can also say, hey, my values could be null. This is where it gets super crazy. So not only can reference types be nullable, but now we can have essentially primitive types be nullable. So I can say, hey, in my student class, my string phone number might be null, and my email might be null by adding a question mark here. Means might be null. So when I go and use student, so here in my form code, then, if I wanted to add more interesting information, right? So I might have my student dot phone number. Oh, where is it here? Student dot. I gotta make those things public, sorry. Public string name. There we go. Phone public. Okay. There we go. To reformat, there's all sorts of shortcuts, but your advanced format documents in here somewhere. It's like Control K and then Control D. Where is it in here? It's somewhere in here. So it'll like do all the tabbing stuff for you. You don't have to tab stuff by hand. Why is it not? Yeah, format E and D. Okay, E and D will format your whole document. It's like if it's tabbed funny, it'll fix it for you with E and D. All right, so now I can go get at my student, right? So student dot, and now I get email, right? And maybe I want to do something with it. Maybe we'll take the student label dot text email. So maybe we add this before the new line. Maybe we do a new line at the end here. Nope, student label text. I can't spell student label. That one. Plus the email, there's semicolons. But they might not have an email, right? It might be null. So if you've made this the nullable type, we can check and say, hey, if my student.email, what is it here? Dot value? Where is it? Dot. It's not null. Can add an email addresses. This is kind of silly because if we had email, we probably should add it to the toString, but we can add all sorts of checking to it if it's a null property. And we know at this point, even this the suggestion here is telling me when I hover over it that email is not null here, right? Because it knows it's inside of a check to see if it's null, right? Or you could say not equals null, whatever you like here. Right? It knows it's not null. If we go to else, right? I go to student email, it's going to know that it is null here. And I hover over it. It may be null here. It's a very helpful suggestion. Right? So you can add in sort of checking here on all of your types. It gets to be a little bit fun. So you can mark them essentially as might be null when we go into these things. So you can disable null checks if you want here. There's some ways to do that. Generally, we don't do that because it's nice to know that it's null. So when we're dealing with things that might be null, again, that question mark lets us go and do something with it, right? If it's null or if it's not null. So you can sort of chain all these things together here. So if my students is not null, right? So students does not equal null, and then maybe I want to get index, which was it? Find, yeah, we can find a student, so I have to give it a match of a student, or get, is it get first? Wow, I can't work lists anymore. That's sad. Is it index of? Sort? We haven't done a lot of these ones yet. We'll get to those ones later. Is it at? Not even at. Add, search, clear. There's too many of these. Find. Index of. Is that it? Index of? It's not even. All right. If it's not null, right, we would get the student out. We can use find, but. That's not what we want to do. Hang on. Sorry. Students. So we get students. Add. I don't want to add. Single? Take. This is not great. Where is it? Is that a list of students? Get by index. I really shouldn't have to Google this. Oh, just use the index notation. Okay. Sorry. Students, square braces, index of 0. I wanted a method here, like the at method, like vectors. I've not had enough coffee today, I'm sorry. So if it's not null, get the thing at the first index. If that's not null, then go do something else. So you can like chain these not nulls together instead of having a bunch of ifs, right? Because if you can do something on 7 lines, why not do it on 1 line? That's sort of the whole idea. So if it's not null, then I would maybe get my email, and if that's not null, then I can go do something with it here, like go see if that contains the character @ sign, right? If it has an @ sign, then it's probably a valid email address. I don't know. Does the email address of the first student have an @ sign? Some sort of weird something or other. But all sorts of chaining this together, because it's just shortcuts, right? A lot of what we see here is just ways to make this faster if you remember the crazy syntax. So if you see all these chains of question marks, question marks, question marks, question marks, right? Because the students list could be null, the student could be null, the email address could be null, and we don't want to have to indent and indent and indent and indent and indent a bunch of times. At some point, right, if we keep on tabbing in for null checks, when you have like a student might have a list of classes that might have had the I don't know, a list of assignments in here, and that list of assignments might have had scores in here. Like if you're 7 tabs in, it just gets really hard to read. So one of the goals is to have the least amount of tabs here. All right. Get rid of that one. All right, so nullables, right? So big, long, ugly lines as we go. You can also use the null classing operator. That's a fun word here. So if it's null, give it something else, kind of like that ternary expression. So if it's null, return something. So we can say, hey, if my sections are null. So maybe I would say, hey, if section's null here, I could say list of students equals my section get students, and if that one's null, then maybe make a new empty list so I don't have to deal with null everywhere else in my code if I wanted. Now I can't do this var thing down here, but so this can check to see if it's null. It gets back null, a new empty list. Wow, you see that stayed colored? I think my Visual Studio is really upset. Okay. More shortcuts, right? This is, instead of saying if it's null, do this, else do this, right? Just like the ternary operator. If you say assign it this value if this is true, else it's false, assign it this value. Just a shortcut. Null forgiving operator. This is fun. You can add in your exclamation mark and your compiler warning goes away. It's because the compiler usually warns, hey, these things might be null. Just tell it, no, it's fine. But generally it's a little weird to have in here. So you just might see it. Okay. Cool, moving on to more fun things. So object-oriented design stuff. So we'll get through inheritance and polymorphism probably tonight, and then I think we'll probably leave interfaces and generics and records for next week, and that'll close out this section. So when I say polymorphism, you don't have nightmares of 200, right? CIS 200? You got through that okay? Right? You can treat the child class as the parent class, and then at runtime, the right method gets called, which is kind of magical if you think of it. Like, how do I have a list of polygons and somehow I get the right area out if it knows it's a triangle or rectangle? Because you don't know how to compute the area of a polygon. The rectangles and triangles know how to, right? That fun, did you do that fun example? Is that worth doing? Okay, it is worth doing. We shouldn't skip. Okay, we'll make it. Let's add a new class. So let's make a class for Polygon. So Polygon probably has a list of integers here for, I don't know, side lengths. And again, we probably don't want the gets and sets here. It's okay. Might not matter, but we'll save this whatever here. And we'll have a string for name with gets and sets. Let's make that a public string for name. This will be my private list for ints. And then we'll make a class for Polygon that has an integer for number of sides as an argument. So I can make side lengths equal a new list of int given number of sides as the size there. So you can tell it how many it'll have. That's one of the overloads of list. So when you make a list, you can tell it empty will be an empty list, or you can give it an initial capacity. Right, we're just using one of those overloads. It's my number of sides. Now, it's probably going to start off with all zeros because integers are pretty nice like that, but we could go through and loop and set a bunch of zeros if we wanted. So number of sides, we probably also want a string for the name then as well, right? So we can set my name as name. And then we need a way to set the side length and a way to get the side length. So public int for set side length, given an int for the side length, and the int for the side index. Right? Which side is this one at? And I can take my side lengths at that index, the side index, right? Side index is the side length. Oh, that should be void, sorry. So we'll go set it here. Nope, that's side lengths. There we go. There's my S. Right, then we can go get a side length. So an int get side length. Give it an int for the side index. Return my side lengths at the side index. Sure, so I can get and set. Now this will crash if you give me bad indexes. That's probably fine. I could have other special handling around it if I wanted, or I can just crash if you ask for the wrong index. Either way, it'll be okay. Names of properties, that one's easy there. And now I don't even give you a way to get the entire list. I just say, here's one at a time. Okay, well, that's probably fine here. Then if I wanted to make a new class, right, that inherits from this class, oh, I'm sorry, we got to do a public int get perimeter. Or we can just call it perimeter, right? Perimeter, this is just a computed function here, right? We can give it a little arrow notation. Right, that's the sum of the side lengths. Sum, is it side lengths dot sum? Just sum the side lengths. So it looks like it's a property, but we're only ever getting values back out. Right? Again, we saved two curly braces. So very exciting. So I can get that one out, and then I don't really know how get area works, right? But I might be able to have an area, so maybe we'll call it area. We can throw a not implemented exception. It's all sorts of fun built-in exceptions in C#. So not implemented means it has not been implemented yet, right? When you try and use it on a polygon, we can't do that, right? Because we don't know what kind of polygon it is necessarily. Okay. Now if we want to inherit from here, we'd go and add a new item, like how about rectangle? We'd say rectangle, then colon is going to be a polygon. And now right off the bat, it's upset with us because this is no argument given that corresponds to the required parameter number of sides of polygon.polygon int string. Right? My polygon class has a constructor that needs the number of sides and a name. You can't make a polygon without calling this constructor. We don't have a default constructor. We don't have one of those no argument constructors. So we can't make one until we call this constructor. So we need to go and do that. So we don't want to generate, we want to generate the constructor here. I think both of those are the same suggestion. So we're going to make a constructor for rectangle. Now we don't need the number of sides because we know how many sides a rectangle has, right? They always have 4 sides? Okay. So we can just say, hey, give me a string for the name here, like I'm a small rectangle, I'm a purple rectangle, I'm a desk, I don't know, whatever you want to call it, right? And then to call the superclass constructor, we say base the base class. I don't know why they keep switching terms around here, but you have base class and derived class is one of the terms here, or child class and parent class, or superclass and subclass. I don't know who came up with all the terms, but so our base class is the polygon class. So we'll call the base class constructor, and it knows, hey, that's polygon, number of sides in string for name. Great, so now we have rectangle. Now we can add a override for the int for get area. Now, get area then is going to return, not return 4, that's weird. Oh, is it just called area? Sorry, it's just area. Area, and this will return, so this is length times width, right? So when we, that's our, is it our side lengths? Get side length, sure, of 0 times get side length of 1. But now it's still upset. It says it can't override it because it's not marked as virtual, abstract, or override. So in the language, if you want something to be overridden, right, we have to mark it as a virtual function. So in Polygon, I can say, hey, this is a virtual function. I want this to be overridden later. If you don't add this in, you can't override it later, right? It won't even compile, which is kind of cool, right? We can protect given functions here, so we can't override it. Now area's happy. We got a nice little cue here that, hey, this is overriding something else here. Now the other problem we have is set side length. Right? If our class is supposed to protect its integrity, this idea of encapsulation here, if I can go set side length 0 to a value that's different than side length 2, you're no longer a rectangle, right? Because then your lengths don't match, right? Or side length 1 and side length 3, then your widths don't match. Okay, so we need to change the behavior of side length. So we're going to say public void or override void set side length. Give it an int for side length and an int for side index. And it's going to complain again here that it's not marked as virtual. You can't do that unless we go mark it as virtual here. Okay, so let's go mark this as virtual. Set that one aside as virtual. Now I can go change the behavior. So to keep them the same, then I need to go call my superclass. I need to go call my polygon. Was it polygon dot? No, this dot set side length. I think it's, is it super? Base. There we go. So we're going to set the side length and, well, we only have 4, right? So maybe we say, hey, if side length is, I don't know, modulus 2 is 0. Those are the even ones. Right? A lot of different ways we could check it here. But how about if it's an even number, we'll set the 0 and 2. Oh, no, leave the length. The index is 0 and 2. Otherwise, we'll set indexes 1 and 3. Right, this keeps making sure that we set them in pairs. Right, so if you want to set either the length, either lengths, we'll set them both. If you want to set either widths, we'll set them both. Right, so we can change the behavior of our parent class to make sure that as a rectangle, we're a valid polygon still, which is super fun. And then this constructor is pretty much empty because we just send name up to base class. Right, but we know we have 4 sides. So now we can get area. We actually know how to implement this, my length times my width. And if we wanted, we could also have our constructor take a length and width. Right? We could have a int for length and an int for width. Or we could give those defaults, right? Maybe default them to 0 if you don't tell me otherwise. And then we can call set side length, given length and 0. Oh man, too many. There we go. And set side length given width and 0 and 1. Right? Set the index 0 for the lengths, index 1 for the widths. If you give me values, if you give me zeros, I just set them to 0, so that's fine. It's not going to hurt anything. But now I have an easy way to make a rectangle if you want to give me a length and width here. Okay, and then triangle, right, is obviously a little bit different here on how it computes that. So maybe we have a class for triangle. So triangle then is a polygon, right? And triangle, we know how many sides triangles have. They have 3 sides. Still might have a name, sure. Now, do we want like base and height for triangle? Doesn't really set our side lengths, but we could, if we know base and height, we can compute the area. There's a way to do that, right, without triangle area, without height. This one. The semi-perimeter of the triangle. This is the coolest thing. Trigonometry is super interesting. This one hurts my head though. Yeah. Sure. So the semi-perimeter is going to be half of that. So sure. Do you want to take length 1 and 2 and 3? Or, I don't know. Just call it triangle. Just leave it here. So we want to have a override for get area, for area, right? We don't want base area. We want the square root of, we need, so we'll have our semi-perimeter, perimeter is get perimeter, it's just perimeter, right? Perimeter divided by 2. Method group, what? Perimeter, really? Oh, did we make that a function? We did. I made it a function. Sorry. We didn't need that. There we go. Perimeter divided by 2, and then we can return math.square root of the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. Sure, it probably works. So semi-perimeter minus get side length of 0 times the semi-perimeter minus the get side length of 1. This is getting a little long here, but that's okay. The semi-perimeter minus get side length of 2. Right? Why is it not like that? Uh-oh. It's upset because we have a double and we told it that it's an int. Right? Definitely not going to get a whole number out of this formula. You're probably not going to get a whole number out of this formula. So maybe we want to change this to type double. Now, this one's happy, but now it doesn't match, right? We can't override. Okay, that's fine. So let's go change it in polygon. Say this will probably be a double for area. And we're fine. Now we can do triangle area. Right? So I can make a list of shapes, and I can get all their values out polymorphically. So let's go back to our form. So we got students, and students probably have shapes for some reason. You probably carry a bunch of shapes in your backpack. Right? Why not? We're making things up here as we go. So let's add, what do you want to do, some buttons? So let's do text box, and text box, and some labels. Wow, copy paste is slow. I forgot, copy paste is really slow. Should have just dragged a label in. Call this one length. Oh, now there was a fast copy paste. We'll call this one width. This will be my length text box. This will be the width text box. This will be add rectangle. Right, so when we click this, we want to add a rectangle. So my class here then might have a list of polygons for my polygons. And again, the constructor should set that, right? Polygons is a new list of type polygon. So when I click that button, I can take my polygons, polygons, I can add a new rectangle. Now I need the length and width, right? Or name here, so I don't know. Sure, rectangle. And then if it's an int, right, int parse, given the length text box dot text, and int dot parse the width text box dot text, text box. Okay, so we added a new rectangle. No, my parentheses are wrong. There we go. Now we match. All right, so we can add that. Then we can add another set of buttons, labels. Just add a button. We'll just add a regular triangle here. So this will be add triangle. When you click add triangle, we'll just take our polygons, add a new triangle. Well, I don't know, triangle. But now I have to set those lengths, though. They're going to be 0 by default. Uh-oh, so that's probably not what I want to do. So maybe our triangle equals my new triangle, and then I can go set the lengths. Triangle.set side length of, I don't know. How big should our triangle be? 1, 2, and 3? It might not actually be a legit triangle, but that's probably okay, right? But 3, 4, and 5 I know is a triangle. We can do a right angle triangle. I know that one's true, right? And that should be a height of 4 and a base of 3, or either way around. So the area should be 6, right? 1/2 the base times the height. So the semi-perimeter is going to be 12 divided by 2 is 6. The semi-perimeter is 6. So 6 minus 5 is 1. 4 minus 3. 6 minus 4 is 2. And 6 minus 3 is 3. So 3 times 2 times 1 is 6. So square root of 6. Is that going to be the... Oh man. Does that seem right? I can't do the math in my head right now. That's fine. And then we'll make a label and we'll print out all of our polygons. We want polygon, not a text box, I want a label. This will be our polygons label. Polygons. Right, and anytime we add a button, we want to go update our polygon label. So maybe we add a function for it. Void, I don't know, update polygon label. So my polygon label dot set text, or dot text, come on, text, polygons, and then for, I can say what, var polygon in polygons. For each, there we go, for each. At the polygon, well, that's not going to work unless I add a toString, right? So we can add a toString. So public override string toString. We're going to return, I don't know what, the name and the area, and oh, sorry. Our perimeter. Is that it? Perimeter? I don't know if we need these. Yeah, okay, I did need those. There we go. I wanted those. My bad. Keep those in there. Perimeter. Name of the capital. All right, so we get the name of our shape, the area of the perimeter. But area is not going to work for a regular polygon. But somehow when we add the shapes, and when the list is type polygon, to the magic of polymorphism, we'll treat them as their child class type. All this for a little bit of magic. Let's see if it works. Uh-oh. Gotta build errors. Right, area. Oh, this is not double. There we go. I forgot I didn't change the other one. All right, so now we can add a rectangle. Oh, I forgot to add text in the text boxes. All right, so what, 3 by 4 for a rectangle? Uh-oh. Index is out of bounds when we set the side length. Let's see, so our side length is 3, side index is 1. This side length is 0. Oh, what happened to our side lengths? Did it not create the Number of sides? Okay, so something must have happened in our constructor. Let's go back. Let's take a look at our constructor. Let's add a rectangle 4 by 3. So this, yes, oh, it's 0. Didn't we give it the number of lengths? 4? Let's check polygon. All right, let's try that again. 4 by 3, add a rectangle. All right, so now we said we have 4 sides and our string is rectangle. So new list for number of sides. Now we have my side lengths. Why is the count 0? Oh, all right, so the capacity didn't give me the defaults, I'm sorry. So we still have to loop through. So for int, x is 0, x is less than number of sides, and x plus plus, add 0, sure. We'll add in the zeros. That's a bummer. But it's pre-sized, so we won't have to do some resizing. We'll try that. There we go. So now 4 by 3. Take out our breakpoints. Oh, I didn't call my method here yet. To actually use the update polygon label. All right. Now we should be able to update our label and get a new rectangle. 4 by 3. All right. Area is 12, perimeter is 14. Great. We're trying. Oh, we forgot our new lines. Area is not a number. Uh-oh. That seems like a bad computation. Let's go put a breakpoint in. Get area. Let's try that again. Get a triangle. The semi-perimeter, right, is 6. Okay. So get side length is 0. That should just be a double, right? Is that not? Debugging this is annoying sometimes, sorry. So let's do result. Is this? I want to see what the value is. Return result. All right, so what is the result? Why is it not a number? Do I get side length fail? Bless you. What is my, this side length 3, 4, and 5? It should have worked, right? How did that not work? Get side length. Did I mess up the formula? Might have messed up the formula. Isn't that it? Oh, s times that value. Okay, the square root of s times that. Is that what it is? Yeah, okay. I blame math people. So my semi-perimeter times that one, times the next one, times the next one. Oh, no. I didn't do order of operations, folks. I spent a whole, 5 minutes complaining about it, and then I didn't do my own parentheses. You're supposed to catch that when I do dumb things. You get bonus points if you catch me doing dumb things. All right. So do the arithmetic, the subtractions before the multiplications. Right? Otherwise, we're having get side length times the semi-perimeter before, right? And then that minus, because the way I have my multiplications in here. Okay, let's try it. Let's add a triangle. Let's see if it computes now. Is result a real number? Hey, result is 6. It worked now. And this was cool. I didn't even have to stop and start. Notice I just changed the code. You know, it ran the new version. That's super fun. All right, so now we get our perimeter of our polygons. And we get 6. Again, they're always 6 because that's what it was. You guys look bored. It's after 7. Should we take a break? All right, let's take 10. I'll come back in a little bit.